Multiplying and dividing radicals is not much more difficult than multiplying and dividing integers. So for instance, if we have root 3 times root 2, all we need to do is multiply the two radicands, 3 and 2. 3 times 2 is 6, so root 3 times root 2 is root 6. And in general, we can write root a times root b is simply root a b. So let's say we have root 5 times root 5. We can, of course, multiply the 5 and the 5 and write this as root 25. But just stop for a second and take a look at what you're doing there. You're actually multiplying the square root of something by itself, meaning you're squaring the square root of something, which is just simply going to take away the radical sign. And you can see by simplifying root 25, which is 5, that you just end up with the radicand. So save yourself a lot of time, and when you recognize you're just squaring a square root, just take away the radicand, or the radical sign. So root a times root a is just simply a. So let's take a look at a few more examples. Root 6 times root 7. 6 times 7 is 42, so this is simply root 42. Let's try another one. Root 6 times root 2. 6 times 2 is 12, so this is root 12. But from the last lesson, we learned we can simplify radicals when we can take out a perfect square factor. And root 12 has a perfect square factor, so it can be simplified, and you should always get in the habit of simplifying the radicals when you can. So the perfect square factor is 4, therefore this can be written as root 4 times root 3, which is simply 2 root 3. However, there's a much more efficient way of doing this. It's generally better to look for factors first rather than when the numbers are much larger, because that takes a lot longer. So when you look at root 6 times root 2, try to identify if there are any common factors in the radicands. And there are, or there is in this case, it's 2. So we can write root 6 as root 3 times root 2, and then we're multiplying that by root 2. And now you can see you've got a product of two radicands, or two radicals that are the same, root 2 times root 2, which is just simply 2. So we can write this as 2 root 3. Now, in case you're wondering, you could write it as root 3 times 2, but the standard convention is to put the integer part first and then the radical part second. I think that's to avoid any confusion of where the radical sign actually ends, so you don't get it confused with root 32. Let's try this again for root 10 times root 15. Identify any common factors with 10 and 15. There is a common factor of 5, so break that out. Root 10 becomes root 2 times root 5. Root 15 becomes root 5 times root 3. I chose to write the root 5 side by side so that we can see we've got a product of two root 5s. And when you multiply root 5 times root 5, you just end up with 5. We still have the root 2 times the root 3, which is root 6. But this is much more efficient than multiplying the 10 times the 15 to get 150, and then looking for a perfect square factor of 150. In general, the larger the number, the more difficult or time-consuming it is to look for factors of it. Let's take a look at division. Division, again, is just pretty much like division with integers. Root 6 over root 2. If we take 6 and divide it by 2, we get 3, and sure enough, the result here is just root 3. So in general, we can write root a over root b is simply root a over b. However, you don't want to do this if a over b doesn't yield an integer. In general, you want to avoid having any kind of a fraction as your radicand. You want your radicands to be integers. So you really don't want to do this very often. Let's just take a look at what we're doing really here to simplify root 6 over root 2. Again, it's just like the multiplication example. We're looking for common factors in the numerator and the denominator, and 6 and 2 have a common factor of 2. So if I write root 6 as root 3 times root 2, and then I have the root 2 on the bottom, I've got that common factor in the numerator and the denominator, and we saw from simplifying fractions that you can just cancel that out because root 2 over root 2, anything over itself is just equal to 1, and so we're just left with root 3. So when you're faced with something like root 15 over root 10, instead of just dividing 15 by 10 and getting a fraction, it's far better to look for common factors. So the common factor in this case is root 5, so we can write 15, or root 15, as root 3 times root 5, and on the bottom, root 10 is root 2 times root 5. Now we've got the common factor there, root 5 over root 5. That just cancels out, and we're left with root 3 over root 2. And that's simplified. Now, in some contexts, having a radical in the denominator is not considered simplified, and you'd want to do a further step. But for now, this is perfectly adequate.